Hello Inventor enthusiasts, welcome back to my channel. My name is Lance Skelly. Today we will be diving into another session on the powerful Autodesk Inventor feature iLogic. In today's tutorial, we're going to explore an exceptional tool that will save you a lot of time by automating component naming within Autodesk Inventor assemblies. Before we jump into our demonstration, I'd like to provide a brief overview of what this rule does. The rule we are introducing today aims to automate renaming components in the browser. This will then serve as a place where we can tweak and perfect the names without risk before we apply the new name to the file names and automatically replace references to the files. In essence, this rule streamlines and automates multiple component naming and formatting chores. With a user-friendly interface, you can easily select components and decide on a naming or formatting operation. This ensures a uniform naming convention across an assembly, saving you time and neatening your models. Before we get started, this video will be divided into two parts. In the first part, I will simply show you what the code does. So, if time is against you and you just need a solution to implement immediately, you can run through the first demo to get an idea of how the code is used, see what it does, and paste it into your own iLogic browser. In the later part of the video, we will dig a bit deeper into some of the special features. But for now, let's dive into our first demo to see this tool in action. Okay, so in this example, I'm going to use this model which I generated using another model that I downloaded from GrabCAD. Let's have a look at the original model. This is the model that I downloaded from GrabCAD. Many thanks to the original creator of this model, who is credited in the description below. Anyway, this model was made using SolidWorks, and when I imported it into Inventor, it brought it in as a single part that has all these solid bodies, as you see over here. So I saved it as it is over here. It's saved into an Inventor part, and then when I used the Make Components feature, I ended up with this assembly that has these individual parts in the assembly. So we are left with an assembly with parts in it called things like Solid 1, Solid 2, Solid 3. That is the way that these parts were generated using the Make Components function. So if we open one of these parts, we can even see, yes, its file name itself is Solid 1. Now correcting all of that is going to be quite a process if we have to do it one by one by one. And if you're anything like me, you would prefer your files to be called something more intuitive, like your channels, you want them to be called channel 1, channel 2, channel 3, and your plates, you want them to be called plate 1, plate 2, plate 3, that sort of thing. Now fortunately, Inventor has got all sorts of tools built into it, such as iLogic, which will help us to automate this process. So today I want to show you a rule that I wrote called Auto Browser Renamer, and to show you how it works, let's select some channels. So I'm going to go ahead and select all of the channels that I can find in this model. And I think that's all of them, and let's click Run. Now this dialog pops up, which has a whole lot of features. The one we want to use today is substitute text. So what we are going to do, we're going to click OK, and it gives me a list of all the files that I've got named, and they're all called Solid 1 and Solid 25 and so forth. Everywhere where we see the word solid, let's say the word we want to change is solid, and then we go to the next dialog. We want to rename that to channel. and a space, so that we've got a space between the word and the number. Then I click OK, and it says that it corrected 14 out of 14 names. And let's drag them all up to the top so that we can see the files that we've changed. So now all of those are called channel. So let's select them all and turn their visibility off so that we know how many more items we still need to do. Right, and next let's go for the beams. So I'm going to go ahead and select all of these columns, and let's run the rule. Once again, we're going to say substitute. So everywhere where I see the word solid, instead I want to see the word column. So I click OK, and that's what I say. I say solid gets substituted for column with a space. 4 out of 4 names were changed. Let's find those files and drag them all up to the top again, and we can turn their visibility off so it keeps a bit of a to-do list for us. Okay, so next I'm going to target the plates. Let's see if I can select all of the plates. Once again, if I don't select them all, that's not the end of the world. I can always come back and do the rest of them later. But let's get as many of them as we can on the first run. Okay, so that's a whole bunch of plates selected. Let's also get those there on top. And let's not forget these plates. Alright, so now we run the rule again. And once again, we're going to say we would like to substitute text. And once again, everywhere where we see the word solid, we would prefer instead to see the word plate with a space. 44 names were changed, and we can drag them to the top again, turn all their visibility off. Alright, and it looks like the only items that are left are all going to be flat bars, so we can go ahead and select all of them, run the rule, substitute solid for flat bar. Click OK. 50 out of 50 names were changed. And let's switch all of the visibility on. Alright, so now we've got an assembly with display names on all the parts that seem to make a little bit more sense. But I know there's another thing that's still going to bother me. That's the amount of digits that I have in 103, for example, versus the amount of digits that I have in 65. So I want to standardize all of these to have 3 digits in the number. So what we can do, we can select none of them, run our rule. Without any components selected, it is going to ask me, would you like to select all of the components? I will say yes. And what would I like to do? I would like to change the leading zeros in the display names. So if I click OK, it's going to ask me how many digits I would like. I'm going to say 3. And it's going to take a while to rename them all. And all of them are now 3. So everywhere where there were 2 digits, now there are 3. Alright, so now we've renamed all our display names and they're looking really good so far. But let's take a look at what happens if we open one of these files. you can see that the file name still hasn't changed. So up until this point, we've only been changing the display names and we haven't been making any changes to the file names. This actually suits us well because it allows us to use this as a sort of practice run where we plan everything out in the display names before applying it to the files. But how do you apply it to the files? Well, our rule has got something built in to do exactly that. And to activate that, we will run the rule. It's asking me if I would like to select all the components. I'm going to say yes. And then I've got an option right at the bottom where I can rename file names to match display names. Let's go ahead and click OK on that. It's going to take a little while it's generating all the files. And it looks like it's done. So what happens if we open this file now? I'm going to open it, and the file name has changed to exactly what I expect it to be. And if we take a look inside the folder, we can see that all the files have been generated. So all these new files that have been generated are now referenced by the original model. Alright, just to recap what we've explored so far. We started with an imported model from GrabCAD, which came into Inventor as a single part with various solid bodies. After using the Make Components feature, we ended up with an assembly with generic names such as Solid 1, Solid 2, and so forth. With our Auto Browser Renamer rule, we efficiently changed these generic names to more intuitive ones like channel and column, plate, and flat bar. We also made sure that the numbering had a standardized format by ensuring that all the names had 3 digits. Lastly, we not only renamed the display names, but also applied those changes to actual file names, ensuring consistency. Bear in mind that the assembly we just looked at had 112 individual components. Imagine how long it might have taken to open each part and individually save it as a channel or plate or flat bar. Then, once all those files had been saved, you would still have to go into the assembly and use the replace component command on each file. What could have taken hours on a large project, we have done in just a few minutes. Now that you have a grasp of the basic features of our script, in the next section we will delve deeper into some more advanced features. We will learn how to use templates for some batch renaming of parts. We will learn how to insert specialized fields like dates, iProperties, file names, counters, and many more into our part names. But if that is not for you, you can get links to the code in the video description and get straight back to your Inventor projects. But before you leave, remember to give us a thumbs up on the video or share it with a friend who is crazy about Inventor. If you have any questions, be sure to leave them in the comments below. For those who want to dig a bit deeper into this automation tool, let's get into it. Let's start by taking a closer look at the options available when we first run the rule. When we run this rule, a dialog box appears as shown. As you can see, the dialog box is divided into 2 sections. The bottom section provides a list of selected components. In this example, channel 025, column 082, plate 030, and so forth. The top section presents our available options, ranging from cancelling the operation to changing the actual files on your hard drive to match the display names. The first option is Do Nothing or Cancel. When you click this, the script will simply exit and nothing will be done. The next option is Rename the display names. With this option, the user will be prompted for each selected component to input the new display name. Next, we have an option to substitute text within display names. This operates similarly to the replace function in many text editors. You'll be able to replace old text with new text for each component selected. The Change Display Names using a template option allows users to modify a batch of display names using a user-defined template. This template can insert fields such as dates, iProperties, parameters, and counters. The next option modifies the number of leading zeros or the total digits in the display name numbers. Rename display names to match file names offers a way to reset all of your changes, making the display names match the original file names once more. Lastly, rename file names to match display names applies the changes you made to the display names so that the file names correspond with the display names. Now let's explore the first option, rename the display names. The initial window that appears is a dialog asking if you would like to group similar files. Selecting Yes ensures all files with the same path and file name are grouped under the same display name. Selecting No assigns unique names to each part, even if they share a path and file name. From this point, the script cycles through all selected components. Users manually input names one by one. The dialog already displays the current name, so to retain that name, simply press Enter and proceed to the next name. The subsequent option is Display Names Substitute Text. Here, users are prompted to input the text they wish to replace and then specify its replacement. This functions similarly to the Replace Text feature in various text editors. Every instance of the old text is substituted with the new text. The next option, Display Names using Template, is a batch renamer that employs templates for automatic file renaming. Users have the flexibility to add fields. These fields, encapsulated in square brackets, follow specific syntax and can include counters, dates, iProperties, model parameters, etc. Within a template, users can combine multiple fields and text strings. Let's consider an example where the text says plate followed by a space and then a field identifier. The field consists of three components. C signifies the type of field, a counter in this case. The first one is the starting number, and the second one denotes the increment. This format yields results like plate 1, plate 2, plate 3, and so on. By adjusting the start number and increment, users can produce a diverse range of naming sequences. For instance, changing the start number to include leading zeros will adjust the counter to include the same number of digits. In this example, doing so will result in plate 01, plate 02, plate 03, and so on. Let's see if we can tweak the field for some more control. For example, changing the increment to 2 results in plate 1, plate 3, plate 5, etc. Adjusting the start number to 2 delivers even numbered sequences like plate 2, plate 4, plate 6, and so on. The next type of field we will examine is dates. The date field is identified by a D. This is shown in the example provided. To delve deeper into the syntax, plate represents a piece of text. D signifies today's date, and the subsequent user format denotes the desired date format. In this instance, the result is a list of names where each name is plate followed by today's date. If we want to alter the format by removing the dashes, we can simply eliminate them from the template. As a result, the list of names will be devoid of dashes. Suppose we wish to incorporate a counter. We can introduce the counter C with a starting number of 3 and an increment of 3. The resulting list would resemble the initial one, but there would be a counter at the end, resulting in components ending in suffixes 3, 6, 9, and so on. Additionally, the format can be adjusted to include the time. In the demonstrated example, each file would be labeled plate followed by a date stamp and then a timestamp in brackets, and finally the same counter added at the end. There are 3 distinct types of date fields. The first, indicated by a D, represents today's date and time. Fields denoted by DC refer to the date and time that the file was created. Lastly, fields with DM represent the date and time the file was last modified. The format is highly flexible, accommodating almost any design. It can include full month names, abbreviated month names, weekday names, and even fractions of a second. Next, we'll explore the file data fields. Fields marked by F simply provide the file name with its extension. Those labeled FE return only the extension, and fields with FP yield the file path in Windows Explorer. These are relatively straightforward and require little elaboration. The subsequent field type is the iProperties field. This incorporates the value of an iProperty into your display name. The syntax consists of an I marker, followed by an iProperty name as illustrated. An example is given below. More examples of iProperty names include title, description, designer, checked by, company, creation date, vendor, and author. Essentially, any valid iProperty name is compatible. The next field type pertains to custom iProperties. This mirrors the iProperty field but is exclusive to user-added iProperties. This field identifier is marked by the letters IC. These are properties that are added to Inventor by the document's author. The illustrated syntax and example clarify this concept a little further. Moving on, the next field types we will examine are parameter and parameter unit fields. These insert the value or unit of a parameter respectively. The syntax is represented by P for parameter fields and PU for parameter unit fields, with several examples provided below. Okay, let's move on to the next option available in the user interface. Let's say we would like to change the amount of leading zeros or digits the numbers in our display names will have. For this, we select the Leading Zeros in Display Names option. Upon selecting this feature, a dialog box will appear, displaying a list of chosen display names accompanied by a prompt requesting the formatting template. Let's say, for example, we input 3. All numbers in the display names will transform into 3-digit numbers. This was a simplistic use of the feature. However, for greater precision, say if we desire the first number in the display name to be 2 digits, the second to be 3, and the last to be 5, We can achieve this intricate detailing by chaining templates. In the given example, the initial instruction in the chain is 1:3, resulting in the first number in the display name having 3 digits. The subsequent instruction, 2:4, allocates 4 digits to the display name's second number. The next instruction in the chain is 4:2 and assigns 2 digits to the fourth number in the display name. In another example, the opening instruction remains the same as the last example, bestowing 3 digits on the first number. This is succeeded by a call for -1. The minus sign makes it count from the end of the name. In other words, -1 would refer to the last number, which, in this example, 4 digits would be designated. The final instruction for -3 allots 5 digits to the third from last number. If our objective is to format all numbers in the display name, A:2 applies 2 digits universally. The following instruction, a -2:5, confers 5 digits to the second to last number. You can see how this feature provides extensive control, allowing precise formatting for specific numbers within the display names. The next option we will explore is rename display names to match file names. This serves as a reset function, nullifying all modifications and realigning display names with their corresponding file names. It's vital to note that engaging this feature erases all prior edits, resetting to the original state. It is a good option if you want to start over, removing all overrides to the display names. And finally, the last option available to the user is the Rename File Names to Match Display Names option. This should be used if you are satisfied with the changes you have made to the display names. Activating this option creates files with updated names, mirroring the edited display names. These new files are integrated as components within the assembly. In other words, each component will be reassigned a reference to the newly created file. At this point, if you are certain that the old files are unnecessary, they can be deleted. However, a cautionary note: if these files are referenced in other assemblies, they should ideally not be deleted. This is why the option to delete is left to the user. Naturally, this option should only be activated upon complete satisfaction with the display names. An added feature in this iLogic code is the ability to reverse the iLogic action by either clicking the undo button or pressing Ctrl+Z on the keyboard. This function undoes the most recent action, mirroring the standard undo functionality in Inventor. In the context of renaming file names to match display names, utilizing the undo feature will reassociate the original files with the assembly components. Nevertheless, the recently generated files will not be auto-deleted and must be manually removed if deemed unnecessary. That concludes the second part of this video. We have had a look at every option available using this iLogic rule. Our journey spanned several functionalities, from manually renaming display names to employing templates for intricate name alterations. We have seen in this video how iLogic can help us to automate what could have been a tedious task. Imagine how iLogic could help you automate other tasks when using Inventor. I hope you found this tutorial useful. If you did, don't forget to hit the like button to give us a thumbs up. Also consider subscribing for more Inventor tips and tricks. If you have any questions or suggestions, drop them in the comments below. Thank you for watching, and until next time, keep inventing.